Hey, this is me, Rasmika, and I'm here with another question from the exercise of binary operation, and that is question number 7. From NCERT A Classbook of Mathematics by S. Sun and page number 23. So let's start this session. So the question number is 7. Let star be a binary operation on the set of natural numbers given by a star b equal LCM of a and b for the elements belonging to set of natural numbers. Is the operation star is commutative and associative? Identify the identity element with respect to this operation star, and also we have to check which is the element in the set of natural numbers which has inverse. So for the solution, first of all we have to check whether this star is commutative or associative. For that, let us check the commutativity first. So let us take two elements a and b belongs to the set of natural number AB. Then a star of b is equal, what it will be? It will be the LCM of a and b, LCM of a and b, right? Now the result of b star a, it will be nothing but LCM of b and a. Now you can see here, if we take the LCM of any two numbers, if we take LCM of any two numbers, then the meaning is same whether we take the element as yx or xy. The result, the LCM will be the same. So here LCM of AB is nothing but LCM of B and A. So here LCM of AB is nothing but LCM of BA. This is equal. Since this is same, therefore we can write A star B equal B star A. Since this is happening, therefore we can write star is commutative. So the operation star is commutative. Right. Now to check associativity. For that, we all know that if we take three elements in a set, suppose the set is A, then let us take that star is an operation on this set A, then it will be associative when A star B of star C is equal A star of B star C. So in a set, for an operation, if we take three elements in the set and if we can find this way, then only we can say that this star is associative. So here, to check associativity, let us take three elements on the set of natural numbers. Let A, B and C belongs to N. Now A star B of star C is equal, by definition of this star, first of all we expand this bracket, then it will be LCM of A and B, right? Now if I say that if we have two elements A and B and we need to take the LCM of these two elements, since we don't know what are the elements A and B, and here A and B are unknown because I take in generalized form. So if we take another element C with this and operates with star, then it will be LCM of A, B and C, right? Can we say it here? It is correct because you take some examples of it. Let us take examples. I say LCM of 2 and 19. Suppose I say that we need to take the LCM of the numbers 2 and 19. Again, another operation is here. Suppose the another third element is 24. Then, without taking the LCM of these two elements, if we take the LCM of all these three elements, the result will be same. Since we are not getting the values of A and B here, therefore I am taking the LCM of these elements with the third element. Here, the result will be same. Whatever, first of all, we take that LCM of 2 and 19. So LCM of 2 and 19 is 38. If we take later that LCM of 38 and 24, the result, whatever it will be same as the result of LCM of the three elements. So I can write LCM of A and B star C is nothing but LCM of these three elements A, B and C. Clear? So A star B of star C is equal LCM of A, B and C. Again, A star of B star C, it will be what? First of all, expand this bracketed part, then A star LCM of B and C. This is according to the definition of this star. Again, since we have to operate this element A with this part again, so it will be LCM of A, B and C, right? If we separately take LCM of B and C and then again take the LCM with A, the result is same with LCM of these three elements. So this part A star of B star C, it will be LCM of A, B and C. Now you can see the right hand side, this is same. The result is same, and whatever in the left hand side, that is A star B of star C and A star of B star C. Therefore, this part will be equal to this part. And whatever this happens, we can say that this operation star is associative. Therefore, star will be associative. Right? So, if we are given an operation star and the definition of this operation says that for two elements A and B, A star B equal LCM of that elements, and the elements belonging to set of natural numbers, then this operation will be commutative as well as associative. So if you have any queries related to this, and if you get more videos on HS second year, then please do write in the comment section so that I can help you. So we have done with this first part. Now next part of this question is identify the identity element with respect to star. Identify the identity element with respect to star. We need to find the identity element also. First of all, you are thinking that what is an identity element, right? Now, so what is an identity element? To know about this, first of all, let us suppose there is an operation star on a set that is A. Now, let us take an element from this set that is small a. Then, if we have an element that operates with this given element small a and results in the element itself. Are you getting it? So if we get an element which operates with this element and results in the given element itself, or if we can have such elements such that a star of that element is equal that element star a, then this element is called identity element, and this is denoted by small e. That is, I am trying to say that a star equal a star of a. So identity element is the element which operates with an element and results in the element itself, then it is called identity element. So we have to find such element in this operation star for the set of natural numbers. So given that star is an operation on the set of natural numbers capital N, let us take two elements from this set of natural numbers. Since the operation is defined as LCM of these two elements, so first of all we need to find that is there any element in the set of natural numbers which operates with an element in the natural number and results in the element itself. That means if we apply the definition of this star, that is, if we take two elements and operates, then it results in the LCM of two elements. So is there any element in set of natural numbers such that for another element a, and suppose this is element x, if a star x equal a itself, or if x star a equal a itself, then only we can say that this is the element in the set N, which is called identity element. So to think about this, since LCM of, first of all we take an element a, LCM of a, suppose the other element in a set of natural numbers is 1, then what will be the result of this? LCM of a with 1, it will be what? It will be nothing but this element itself. Because you already know what is LCM. This is least common multiplier. We all know that 1 is the element with which every elements have the LCM as the number itself. That means what I am trying to say that if we take elements here, suppose this is 100 or x or y or 1000, whatever it will be, if we take this 1 with another numbers and take the LCM of these two, then it will be always that number but not the 1, right? So least common multiplier of a and 1 will be a. So I hope there is no doubt. Since LCM of a and 1 is nothing but the element itself, therefore 1 will be the identity element in this star. And we know that 1 is a natural number, or LCM of 1 a equal a, because the definition of identity element, it was a star e equal a star a. Since 1 star a equal a star 1. Therefore, 1 is the identity element for this operation star on the set of natural numbers. I hope this is clear. So, I'm writing here on this right hand side on this part. Therefore, 1 is the identity element with respect to the given operation star on the set N. And now we have to check which elements in the set of natural numbers have inverses. So the definition of inverse is related to the identity element. Identity element. If we can find an identity element, then we can understand better what is the inverse of an element. So there are videos over inverse of an element in a function and also on identity element, which are the previous videos. You can check the videos and I will give the link of the videos in the description box. Now, what is the inverse of an element? If we can find that there are two elements and the operation of that elements A star B is equal the identity element. If you can find two elements which operates and results in the identity element or in the reverse way, if A star B is equal E equal B star A, that means if we have two elements which operates and results in identity element E, then only we can say that this B is the inverse of the element, right? The definition of inverse says that if we take an element A which operates with another element and results in the identity element, then the other element is called the image or inverse of first element, right? So if this satisfies, then only we can say B is the inverse of this element A. Now in this set of natural number with the operation star, we have to find which elements in N have inverses. Since the star is defined as LCM of A and B. Now, to check whether the statement is satisfied by any elements in the set of natural numbers. If we can find two elements in a set of natural numbers and which satisfies this condition, then only we can say that yes, the numbers have inverse. Now, since the definition is this is important here. That is, we need to find LCM of two elements A and B is equal 1 because we already done that 1 is the identity element. Yes, identity element. So, if we can have such pairs of numbers in the set of natural numbers of which LCM is 1 because 1 is the identity element, then only we can say that the numbers have inverse. Now, what is the LCM of two numbers and that is 1 when it will be? We all know that if we can take two elements, two different elements, if we take LCM of these two elements, then it will never be equal to 1, right? It will be equal to some other numbers, right? Since we don't know the values of A and B, so I cannot find the number here, but I can surely say that LCM of two numbers which are not equal 1, LCM of two different numbers which are not equal to 1 cannot be equal to 1, right? So on the other hand, LCM of a number with 1, this is also not equal to 1. If we take an element which is not equal to 1, which 1, and take the LCM of these two, the result never equals to 1. So what is the pair of numbers of which LCM is 1? This is 1 itself. If we take LCM of 1 and 1, if we take LCM of 1 and 1, then only we can find the result 1, right? So I can say that LCM of 1 and 1 is equal 1, which is nothing but our identity element E. Therefore, 1 star 1 equal 1 equal 1 star 1. Suppose this is A, this is B, B, this is A. Now the result is satisfied, right? A star B equal E equal B star A, but here B and A should be only equal to 1. So 1 and 1 is the only pair of numbers from the set of natural numbers of which LCM is 1. Therefore, I can write the only element on the set of natural numbers n have inverse. So this is done. So what we have learned? We have learned that here identity element with respect to this operation is what? It is 1. There are not many more numbers in the set of natural numbers which have inverses, but there is only one element which is 1, and 1 have its inverse. So I hope this question is clear to you. So in the question we have to check whether star is commutative as well as associative. So we have found that the star is commutative as well as associative, and the identity element with respect to this operation is 1. And also in the set of natural numbers, 1 is the only element which has inverse, and also this is 1. So that's all about this class. I hope you were enjoying. If you were enjoying and if you like my video, then why you are not subscribing to my channel? So make sure that you have subscribed, and also turn on the notification, press the bell icon to get notified. So till then, take care and bye bye.